I'm going to run through how to actually perform a hypothesis test. So far we know how to find critical regions for one-tailed tests, but we've not really properly discussed how to perform a hypothesis test. So I've got two examples that I'm going to go through, and you can obviously watch this back as many times as you like to ensure that you've completely understood the work that we're doing. So the first example is the one that we saw in our last lesson, and I thought it would be sensible for me to just go through this question to see how you should answer it. So the first thing I'm going to write down, or the first thing I'm actually going to do, is highlight the important information from the question. And that is that the standard treatment for the particular disease has a 2/5 probability of success. The doctor has undertaken some research in this area and has produced a new drug, and he's actually done some testing, and he's found that in a sample of 20 patients, 11 out of those 20 actually showed success. And the doctor thinks that this is enough to be confident that there has been an improvement compared to the standard treatment. And we're being asked to test that statement, or test what the doctor thinks at the 5% significance level. So the first thing that I'm going to do is state that X is the number of patients that the drug was successful for. Okay, so that's our test statistic. I'm then going to say that this X fits a binomial distribution, and in this case we have a sample of 20. And I like to write down the probability in here because that's how we do it for a binomial distribution. And we're assuming that that's 2/5. So we're going to say that our null hypothesis is that the probability is equal to 2/5 still, so that there hasn't been an effect. And our alternative hypothesis, the doctor thinks that he has evidence that the probability of success has increased. So that's an upper end one-tailed test, And our significance level that we're interested in is 5%. So what I'd like to do next is find the critical region. Okay, there are other ways to do this, but my method is to find the critical region, because then we're doing the same thing for most of the questions that we are given. Please ignore the dogs if you can hear them in the background. I do apologise about that. So if we think that 2/5 on average in normal circumstances, 2/5 of the patients show successful, show improvement in their condition, or whatever it is that we're testing anyway, then we would expect 8 people to show improvement on average. That would be like the most likely expected number of people. So I know that I can start looking greater than 8. So I'm going to test greater than or equal to 10, 11, and 12. And I'm just going to see what those probabilities come out as. To do 10, remember we need to do 1 minus the probability that X is less than or equal to 9. For 11, we need to do 1 minus the probability that X is less than or equal to 10. And for 12, 1 minus the probability that X is less than or equal to 11. So the next thing I'm going to do is go to my calculator, into the option number 7 on the class whiz, and I'm going to scroll down to CD. Remember, it's CD for all of your hypothesis testing. And I'm going to go for the list option, and I'm going to type in 9, 10, and 11. My N value is 20 and P is 2/5. Oops. In fact, I've just looked at my values and I'm going to need 13 as well. So that's 1 minus the probability that X is less than or equal to 12. So I'm just going to add 12 to my list of values. Okay, and the reason for that is because I needed to see one number below 5% and one number above 5%. And when I'm looking at my data values or my probabilities, I'm seeing one value below 95% and one value above 95%. And that's the bottom two now. This is 1 minus 0.9434 or 35. And the second one is 1 minus 0.9790. Just need to round that correctly. So this value comes out, let me just shuffle this writing over a little bit, at 0.0565, so that's 5.65%, and this value comes out at 0.0210. So 2.1%. So the value that we're interested in is the first one that dips below 5%. So that's the greater than or equal to 13, which means that the critical region is that x needs to be greater than or equal to 13 for us to have evidence that there has been an improvement with this new drug. Okay. Now, what we then do is go back to what actually happened for the doctor. And the doctor found that he had success with 11 patients. So what we can then say is that there is not evidence. So since 11 is less than 13, why have I written X there? Since 11 is less than 13, there is not enough evidence to suggest an improvement in the new drug being successful or more successful. Okay, therefore we should accept the null hypothesis H0, that the probability really is 2/5 and it still is 2/5. Okay, so find the critical region and then draw a comparison. Make a comparison between what happened in that sample, in that experiment, and what the critical region is. If our value had been 15, then we would have evidence that there has been an improvement and we would accept the alternative hypothesis. But because 11 is in the acceptance region, then we accept the null hypothesis. Okay? So I'm just going to do a second example. Now this time my example doesn't have a situation, a scenario. We just have the bare bones of it. So we've got the x is binomial, still 20. That's not particularly exciting that we're still in 20, but we have that the probability is 0.3 for the null hypothesis, and the probability is greater than 0.3 for the alternative hypothesis. And this time we're doing a 10% significance level. So I'm going to do the same thing as before. I'm going to find the critical region, and then compare it to the value of 9 that we got. So finding the critical region again. The expected value is 20 times 0.3, so that's 6. So we know we're testing values higher than 6. So let's go for 8, 9, 10, and 11. And if all of these come out below 90% or above 90%, then we just need to keep going down our list. So to test these, I'm going to do 7, 8, 9, and 10. I won't write all of those down this time. So back into the cumulative binomial distribution on a list, 7, 8, 9 and 10. N is 20 and P is 0.3. And remember, this time we're looking at a value below 90% or above 90% so that it's below 10%. And I can see the two that I'm going to be interested in are the second and the third one. So 1 minus less than or equal to 8 and 1 minus less than or equal to 9. Because this one is 0.8866 and the greater than or equal to 10 is going to be 1 minus 0.952. That corresponds to a probability value of 0.1134 and 0.048. So the first value below 5%, the one we're interested in, is greater than or equal to 10. That is my critical region. So critical region is the first one below 10% this time, remember, below 10%, which is greater than or equal to 10. And because 9, the actual observation value was 9, which that means we're in the acceptance region again, we would again reject the alternative hypothesis. We are going to accept H0, which is that the probability is still 0.3, and say that there is not enough evidence to show that the probability has increased. Okay, so 2 examples there, and both fairly similar. I should probably have done some slightly variation. We've drawn the same conclusion, and they were both greater than questions, but hopefully you get the idea from that as to how you would actually perform a hypothesis test. You know that you're performing a hypothesis test rather than finding the critical region, because they've not stated in the question find the critical region. That is very clear when they want you to write down the critical region. We find it anyway in our method, but the other thing to look for is a value being obtained. So we've got that happening here. A value of 9 is obtained, and that tells us that we need to not only find the critical region, but compare our value to that critical region and draw a conclusion. Okay, so you should now be able to have a bit of confidence working through exercise 7C from the textbook. So 7C is all about actually performing hypothesis tests and checking it against a value that has been collected. So for question 1, for example, the value of 5 is obtained. So we're going to find the critical region and see if 5 falls inside the critical region or not. If 5 is in the critical region, then we would accept the alternative hypothesis. If it's not, we would accept the null hypothesis. But please do make sure you write down your conclusion as to what you are, which hypothesis you are accepting. If it's a question with a context, so I'm just looking down the exercise, I'm looking at question 7. Question 7 is about a dice. You would need to discuss the probability of the dice, whether that there's evidence that the probability is a sixth or whether it is less than a sixth. Okay, I'll leave it there. If you have any questions, please do just email me and I'll get back to you as quick as I can. Do bear in mind that I think some of the answers in the textbook are wrong, but I think the work solutions are correct. So just check the work solutions if you are working in the textbook or with the textbook and you've got a different answer to the one in the back. Okay, I'll see you soon.